Good morning, children. Let me start a lesson, that is fourth lesson, electricity. This is for 10th standard. Actually, this is September portion. Because in between we gave quarterly and other thing, I am not able to take the lesson. But we are taking the electricity, fourth lesson, which belongs to September. So, if I complete this lesson, all the lessons for the till thing will be over. Only few more lessons for us. Let me complete within the scheduled time. I will start the revision from January onwards. Clear? So, it's in page number 42, electricity. This is nothing else. Already we have studied. Every atom consists of electron and protons. Electron negatively charged particle. The flow of electron in a particular direction is known as electricity. That is, what is electricity? The flow of electron. That is, the movement of flow means what? Movement of electrons in a particular thing is known as electricity. First we'll see the definition for the electricity. Then we have to go what are the uses of electricity, what are the series, that is parallel series, circuit series. This and that we have to see now. Clear? First, what is electric current? It's in page number 42. The motion of electric charge through a conductor, that is, motion means what? Movement, flow of electron through a conductor. Through a conductor means what? Particular part through which it goes. Through the conductor only the electricity can flow. Clear? It will constitute an electric current. How the water flows, how the air breezes, like that air comes. So everything like that it is also. So the electric current passes from the positive terminal to negative terminal. First we see electricity is the flow of electron. To pass the electron, what are the things considered for us? Positive terminal and negative terminal. Okay, a positive terminal and negative terminal. So, otherwise, it is defined as, underline in page number 42, it is defined as the rate of flow of charge in a conductor, the same like. The flow of electron through a conductor is known as electricity. Conductor, a material which passes the electricity. It has two things to pass over, one is positive terminal, other one is negative terminal. So now we have to see what are the units. So everything we have to measure, even electricity, electric power, potential difference, everything we have to say. The unit of electric current is ampere. We'll write the units and all here. Units. Because it may be 2 mark question for you. Units of electric current is SI units. SI unit of electric current is ampere. Ampere A. Unit of electric current is ampere A. Clear now? How we can find out ampere? What is the electric, how much of electric current is used by your thing? We can see coulomb by second. That is how much of electricity passes in 1 second. Based on that we are finding out. The important thing is what is the unit of electric current? Unit of electric current is ampere. Then, and what are the components? Uses of the component and symbol. That also 2 mark question you have to match. So that is given in the page number 43. Resistor. It will be like that. Variable resistor. Ammeter means what? A will be voltmeter. This and all instrument to measure the electricity, flow of electricity. So we can do the practical also with this. Galvanometer, G, diode, that is both the side, positive and cathode, anode and cathode. Anode means positive, cathode means negative. Light emitting diode, ground connection, everything will be. Earth connection we are saying no, earth will be. So you know better than me electricity. So earth kuduthirupanga, then one positive terminal, negative terminal will be. So what are the important things I said? What is electricity? The flow of electron through a conductor is known as what? Electricity. It needs positive terminal and negative terminal. The unit of electric current is ampere. This is the tabular column is important for 2 mark question. You have to match. Okay. Then what are the electrical components? We said what is electricity? Electricity flows I said. It has 2 terminal, positive and negative. Then what are the electric components? Components means which are the things required for that? What are the electric components? That is battery. It is connector. The next one is switch and bulb. Suppose you want to glow a bulb. First what you have to say, it should be connected with the battery. You have to put on the switch, then only the bulb will glow. So these are the components. Battery, switch and bulb. These are all very essential for electricity, to flow the electricity. These are known as electrical components. Then next we have to say, electricity has some power to save the, that is electric energy. That is known as what? Potential. So how much of energy, how much of electricity is saved in that? That is known as electric potential. It is electric potential at a point is defined as, it's in page number 44. So electric potential is important. The electric potential at a point is defined as the amount of work done in a moving unit positive charge from infinity to the point against electric force. That is how much of electricity worked from the positive terminal to the electric force. This is known as what? Electric potential. That is how much it holds, how much of electricity it holds in that. So this is known as electric potential. Electric potential, otherwise known as, then that is 2 electric potential is there. The difference between the electric potential can be defined as the work done in a moving unit positive charge from one point to another point from the electric force. So potential differences, potential difference, what I say, the work done from the positive charge to the work done, that is W, charge, that is Q. Potential difference is W by Q. Otherwise we can say potential difference, we can say as V. Unit of potential difference is V. That we can measure by using voltmeter. Electric potential, potential difference both are same. It can be measured by V. Then we have to go for Ohm's law. Based on electricity, Ohm's law is framed. We have to go for the Ohm's law. After completing lesson, I will do the calculation, children. In between calculations are there. That is simplest calculation only. After completing the lesson, we will go for that. Ohm's law. Ohm's law, his name is, he is a German physicist. His name is George Simon Ohm. He established the relation between the potential difference and current. So what is Ohm's law? What does it state? It says about what is potential difference, then how it is connected to the current. This both, what's the relationship between the potential difference and the current is known by Ohm's law. So what is Ohm's law? He is a scientist. He said, what is the relationship between potential difference or potential, both are same only, I say. Potential difference and electricity, current. What does Ohm's law states? Say, you have to underline. He established a relation between the potential difference and the current is known as Ohm's law. So this can be said like this: at a constant temperature, that is temperature remaining constant till the experiment over, there should be no changes in the temperature. According to Ohm's law, what is Ohm's law? It's in page number 45. At a constant temperature, the steady current, that is I, steady current flowing through a conductor is directly proportional to the potential difference V between the two ends of the conductor. So again, at a constant temperature, the steady current is flowing. Steady means what? Constantly it's flowing through a conductor is directly proportional to the potential difference. That is, current is directly proportional to the potential difference. That is, for example, if the current increases, potential differences also increases. Directly proportional. ரெண்டுமே என்ன இருக்கும்? ஒரே லெவலில் இருக்கும் அப்படின்னு சொல்கிறாங்க. ஓகே, again go through at a constant temperature, the steady, because this Ohm's law and all, you have to write as it is law and all, we cannot change. Even a single word is changed, it will be a mistake to us. So at a constant temperature, the steady current I, that is the measurement of current, flowing through a conductor is directly proportional to the potential difference. The unit of the potential difference is what? V. They are between the two ends of conductor. I is equal to V, directly proportional. IV is equal to constant. What is Ohm's law? That is IV is equal to constant. Potential difference V, I say IV. Clear? This is Ohm's law. Then for everything, that there should be a resistance. The current flows, that should be managed by a resistant. The resistance is V by I is equal to Ohm's law we are finding out. The resistance of a conductor. What is resistance? Next we are saying what is resistance. Resistance, that holding capacity. The resistance is, the resistance of a material is its property to oppose the flow of charges and hence the passes current through it. It is a different for different material. V by I is equal to R. That can be different. So resistance can be measured as ohm. Resistance. Unit is ohm. Otherwise we can say as, the symbol is what? Ohm. One ohm is equal to 1 volt into ampere. So 1 ohm is equal to 1 volt into ampere. Volt by ampere. This volt, ampere and all nothing else. It's a unit of electrical things. Electrical resistivity. Resistance you have seen. What is resistivity? The same thing only. It is a resistance of conductor in a unit length and unit area of cross section. This one only we can find out through the experiment. Okay, resistance will be different from different material. For example, conductors, insulator, that is which can allow the electricity to pass through. That is metals which can allow the electricity to pass through is known as conductor. Which do not allow the electricity is known as insulator. So, conductor, what are the conductors? Copper, nickel, chromium. They are the best metal which conduct electricity through that. So, they are known as what? Conductor. So, copper is 1.62 into 10 to the power of 8. The 10 to the power of 8, everything normal for the conductors. Only thing, the number will be changed. So, ohm it is. Ohm. So, copper is 1.62 into 10 to the power of 8. Nickel 6.84 into 10 to the power of 8. So chromium 12.9 into 10 to the power of 8. So which is the lowest conductor means copper. Highest is chromium. Clear? Insulator, that the things which cannot conduct the electricity. They are the poor conductors of electricity. For example, glass, it is 10 to the power of 10 into 10 to the power of 14 within that range. Rubber 10 to the power of 13 to 10 to the power of 16. Clear? So we have seen what are the things we come across so far. What is electricity? What are the things required for electricity? Positive terminal, negative terminal. What are the electrical components? What are the units, SI units of electrical subordinates? That is, electric current is known as ampere. Potential difference, that is, what is potential difference? I say the difference between the electric circuits is known as, that is V. Resistance, ohm. That is conducting capacity is known as resistance. Clear? So, resistor in series. We have seen maybe at a time we can connect 2 or 3 things together. A resistor in series means what? In the groups. If resistors are connected, that is one positive terminal is connected to the negative terminal. Then second is negative terminal is connected to the positive terminal. Negative, positive, positive, negative, like that. We can conduct many series. This is known as what? Resistor in series. If resistors are connected end to end so that the same current passes through each of them. Direct current, AC current, DC current, they will say. So this is because of the connection between the resistors. For example, say in the diagram 4.6, V1, V2, V3. How many resistors are there? 3 resistors. They both are connected together. That is, negative end is connected to positive end. Again, positive end is connected to negative end, like that. Finally, they are connected with the battery, switch and ammeter. Ammeter is the instrument which helps us to find out the electric capacity. So they will flow the same electricity. Electricity will be same only. For example, resistor 1 4.7, it will be increased. Resistor 2 4.8 and resistor 3 4.9. So potential difference we want to see means we have to add all together. Calculations are there, I said already. Parallel connection resistor, the same like that is parallel and parallel connector, a bit is same. They are in the straight line. The connection is given in the straight line. That is known as what? Parallel conductors. Series connection, that is serial sets and all we have seen in the marriage halls and the hotels. Then what else? Then textiles, showrooms. We can see the series connection of parallel resistors. Then what are the differences between series and parallel connection? There are 2 kinds of thing. Now one is series, other one is parallel. Houses and all mostly parallel only. The advertisement purpose and all series. So criteria means what are the headings we discuss under series, what are the conditions of series and as well as parallel. Equivalent resistance, more than the highest resistance, series one, here less than the lowest resistance. Amount of current is less as effective resistance is more. Current is more, effective resistance is less. Switch on and off. If one appliance is disconnected, others also do not work. Where? In series. ஒரு switch disconnect பண்ணிட்டீங்கன்னா எந்த இதுவுமே என்ன ஆகாது, உங்களுக்கு glow ஆகாது. But here, if one appliance is disconnected, others will work independently. So what are the differences between series and parallel circuit? It's an important one. That may be 2 mark questions. So unit and all just memorize. That may be match the following like for you. Next one we have to say Joule's law of heating. Ohm's law we have to say. Next one is Joule's law. It's in page number 50 you say. Joule's law said about the relation between the charge and current. So this is you have taken from Ohm's law. It's based on Ohm's law and only Joule's law also. Totally this is known as Joule's law of heating. So what are the points in that important point? Joule's law, what are the things it's based on? It is directly proportional to the square of the current passing through the conductor, directly proportional to the resistance of the resistor, directly proportional to the time for which the current is passing through. So this is directly proportional to what all? Through resistor, resistance of the conductor and then current passing through. All the 3 things depends on directly proportional to the current. This is known as Joule's law of heating. Then what are the applications of Joule's law? That is uses. This can be used in electric heating devices, fuse wire, filament in bulbs. So let me continue in another class. Before that just go through what are the things we call. What is electricity? The flow of electron through a conductor is known as flow of electricity. It needs 2 terminal. One is positive, negative. Positive will connect it to the negative, negative will connect it to the positive. Electric components we have seen. What is potential difference? And how to use voltmeter and ammeter it will be. And then finding out the potential difference and current is an experiment for you. Ohm's law we have seen. Joule's law. What are the units? SI units we have seen. So SI units are very important. So in between in page number what I said? Okay, thank you children. Let me continue in another class. Okay children, let me continue. So far we have seen what is electricity. What are the different types of series, that is, what are the different types of connection, that is series and parallel, and we have to say how the electricity will be used on the heating effects, application of heating effects. First one you have to say electric heating device. Device means what? Instrument, where and all electricity is used. For example, the house, what are the things we are using? First we have to say effect of heating electricity. So this is first where and all you are used effect of heating. First one is electric heating devices. Where and all we can use the electric current. It's used in many home appliances we are using in our day-to-day life. For example, electrical iron box, electrical toaster, electrical oven, electric heater, geyser, etc. So in these appliances, nichrome, which is an alloy of nickel and chromium, is used for heating effect because this is important. So we are using here, what is the heating effect? Heating element is the household things. What is heating element? Nichrome, and the name itself we know nickel and chrome. It's an alloy. It's an alloy. Why we are using nichrome? Because it has high resistivity, it has high melting point, it is not easily oxidized. For the three reasons only. Underline this point. Why? What is the heating element used in electrical appliances? What is the heating element? Nichrome. Nichrome is an alloy. It's made up of nickel and chromium. Clear? Why we are using? Because of the reason it has high resistivity, high melting point, it is not easily oxidized. Because of the three reasons only, it is used in electrical appliances. Then fuse wire, you know, fuse cut ஆயிடுச்சுன்னு சொல்கிறோம், fuse wire. Next one is fuse wire. First one is fuse. It's a small wire. Fuse wire is connected in series in an electrical circuit. When a large current passes through the circuit, the fuse wire melts due to Joule's heating effect and circuit gets disconnected. If the current is overflow, immediately it will be switched off. Therefore, the circuit and the electric appliances are saved from damage. அது ஃபியூஸ் ஆகிறதால என்ன ஆகிடும் உங்களுக்கு அந்த இது வேஸ்ட்டாக ஸ்பாயில் ஆகாமல் இருக்கும்.